used her model of the slide, so I was worried. Okay, so actually I did take the issue about code preparation here, and I decided on this small talk to focus on that a little bit, and on the other point that we see repeating over and over, which is intellectual property over the whole thing, and in particular of the code. On validation a little bit. So, although we're measuring the visual, which is not easy, as we've discussed here, we've seen it discussed here before, there's still things out there that can help evaluate visualization and compare visualizations to each other, and maybe they should use. So I used the definition, that definition there of validation. On code and data preparation, one thing that we should be worried about is basically nothing, since of course it worked. I think the thing that we should be worried about is also to give some suggestion on how to run it, and I'll come to that later. But intellectual property thing, as it happens, some of our research is funded by companies that require full or at least good part of intellectual property, and just in case, you know. So these are the points I want to point out and detail a little bit. So there was this paper, which is actually a funny paper to a certain extent, in Nature in 2010. Have you seen that? It's very nice. So on intellectual property issue, what he says, the code is valuable intellectual property that belongs to my institution or whoever, my sponsors. Really, a little MATLAB routine and calculate two-part fit is worth money. So basically, you should be thinking a little bit about is it that much important that the code is kept to ourselves or to whoever, because to make that work, it's a lot of work for engineers, for software engineers, to get it out there. So it's probably not a big deal to leave your code available. But it would require change of policy from many sponsors, because it's just a matter of the way things are being done. The other thing is the issues of good standards for code. And what he says in this paper is it's too much work to polish the code. And he also says, for scientists, the word publication is totemic and signifies perfectionism. Something else, and then the original code can be published supplementary information available from an institution or journal website. And so there is no obligation, there should be no obligation as to quality of the produced code. In which case, the person with the code is responsible to decide whether they want to use it or not. And I mean, there are very interesting things about other issues as well in this particular article. But in particular, the academic reasons to share the code would be to enable others to engage in our research. And the problem is, sometimes that's precisely what people want to avoid. I mean, it's an ongoing work, and I know what the next result is going to be, and I want to publish it. So what if my precious code is used by someone and they do it before I do? But expertise is actually at the core here. Are they actually capable of doing that as fast as you can? Oh, in other words, how fast should we make the code available is the only problem here, and not whether we should, because science is not going to be made without reproducibility, at least not in the sense that we wanted it to be. I come to that further down in this same slide. So improve the chance of impact of your research. Chances are, the papers that we see or the techniques that we see repeat are the ones that are the very simple, very nice ideas, but simple in implementation, and people can repeat with reliability, or the ones that were left the code available. Why does everybody use PCA? You type PCA on a Google engine, and it comes 100,000 different pieces of code that will do PCA. There are other things around. Not against PCA, they are very good. It's a very good technique for many things, right? But it's there, it's available, it's quick. And it leads to people referencing your work. Shouldn't we be looking at some numbers that are better than the number of papers that we produced? And isn't referencing a number that qualifies a little bit better the research that we do? And the development reasons. Final products are not all that polished anyway, so the final code that we see here and there is not that great. So are we worried that our testing code with claims of all kinds that are not going to be, we are not going to be responsible for any bugs or anything? Why should we be worried about that? So, another thing is, we know that starting from code and data is better than starting from the words in the paper. Sometimes it looks nice in the paper, it looks reproducible, and I'm curious how Paul judged reproducibility with most papers not having the code available. But you look at it and say, yeah, I could implement that, but when you do, the parameters don't match. So, you run the risk of people doing that with your work and start saying it doesn't work. So maybe we should be giving out the code just, to be on the safe side, because actually that happens sometimes. You do implement that and it doesn't seem to be producing. It's not that it's not producing, it's just that the parameters are the same, or they use a better or more efficient numerical method to solve the system. Or what? There are details they're missing that the code would give out, and maybe it should. I don't know. That's why we are here. So allowing our techniques to be improved and adapted by others, we need to reach higher goals. And I'll join with the other one. Promoting our ideas and techniques helps them to become standard procedure faster. I mean, if you do want your things to be applied, giving out the code and the data may be a way, or one of the ways to do that, unless you advertise, which is also a possibility, right? So, after all, some of us probably got into this business to improve people's lives. Not being naive here, I'm pretty sure that many of us wanted to have the things that we produce used, right? And a particular case I want to highlight is there are many institutions where visualization, which is our business, could be important, that they're not there for profit and they have nicer goals and they need code. So at least, if nothing else, for that reason, the next best choice to you doing that for them, right? So, data sometimes is the result of hard work. So just to produce the data is hard work. So some of us don't want to give it out because, we took 1 month. The biologists, for instance, they take years sometimes to get their data going. And so there are problems with the data itself being the result of someone's research. And also privacy, security, sensitivity issues related to security. In many cases, the data that we presented in the paper is disguised because the sponsor did not want the actual data to be reviewed. But at least the disguised data could be left available for people to try it on. But some things are changing. I mean, we see examples like Rita said here. Reproducibility standards are being supported by various venues, and publishing data may be a form of publication. We've had that going on in many other fields. So from the other fields, I give just a few examples, but we see that happening every time more. For instance, some journals encourage reproducibility as available code and data. So for instance, by statistics, by Oxford journals, they actually they encourage, but they almost require that you leave code and data available And they even have now associate editor on reproducibility to make sure the work is reproducible. One thing that we can do is something that's been observed in imaging processing area, which is you write the papers about the data. Sometimes the data is complex, and that's the problem. So we write the paper about the benchmarks and the data, and then it is a paper. If publishing is a problem, you publish the paper on that. Okay, and of course we see also a lot of benchmarks available these days that maybe we could be doing it with our data. And I have here a timeline, or actually a difficulty line, on possible ideas, right, that we've been hearing here and there. So just release your data, release your code is the easiest way, although we have to go through all these difficulties with sponsors, and I know I don't have obligation with my code, but I'm a perfectionist and things like that. So one idea, one possible thing to do is score on reproducibility in the review process, that I'm calling rate for reference, but we have all those concepts, right? We could have one for reproducibility, just by the way the things described. A couple of questions that submit on code and data availability. Are you going to leave your code available? Because, why? It's not to pressure, although people will be pressured. We all are always feeling like that anyway. It's just so that if you read the paper, you say, oh, these I cannot implement. This cannot be implemented like that, but the author is going to leave the code available. Oh, in that case, it can be implemented. It cannot be implemented the way it's written. Sometimes there's no space to give details, but if you leave the code available, then it's sorted. The reproducibility part of the work in many ways. If you have a good student that programs well, he will understand it, or she will understand it. A word for reproducibility would be a possibility. Call for papers specific on benchmarks. A repository, the floating position there is that it may be more difficult or easier depending on how it's implemented. But could be a repository of techniques presented at V0Vs, for instance. And or the whole pipeline related to reproducibility, like Brita exemplified from other venues. On validation, very quickly, promise. One must verify, of course, should compare, should validate. It is an area that is getting matured, so these things are required. But if you do make your code available, or even if you don't, you should divulge the parameters. It's true what Heike said, that we only present the good results, but then at least you should give the parameters from your technique that produce that good results, so people can reproduce in the same level, and not go around saying it doesn't work, right? If you look at the papers on SciVis and on InfoVis, there are many papers, more than one would expect, that do validate their technique using numerical values. For instance, information theory measurements, mesh quality measurements, and in SciVis, and other numbers coming from InfoVis or VisualMind, like stress, distance plots, neighborhood measurement, silhouette, correlation coefficient. Many other numbers are around that help identify what the visualization is doing with your data and how to compare with the data itself. So it might be a nice idea to take a look at them and use them. Perception evaluation is called for, like we were also discussing before, right? There are many things we don't know about how people look at images and interpret images, and that should be taken into account. Maybe a separate studies. I mean, we shouldn't be pressuring too much to have the user evaluations right there unless it is clearly called for, because it is too much to have in one paper. So clearly I'm all for reproducibility, but having said that, encouragement to release code and data should not restrict initiative. I mean, in some cases, there are very nice ideas out there that are very valuable per se, and not as still in this stage where very hard validation tests can be done. So we shouldn't left out a very nice idea just because it wasn't properly validated with other numbers. And we are validating the visual. Validating the visual is not that easy. I mean, if you manage to have a number that says what the visualization is saying, we probably not need visualization, right? Visualization is good because it helps solve dilemmas and uncertainty and conflict, and that may sometimes make it difficult to have a number to reflect what kind of value that visualization is giving, or that the new technique is giving to the users. Okay? So I should finish.
Thank you.
Thank you.
Thank you, Rosane. Yeah, let's thank you again. Are there like immediate questions to record? Yeah.
Maybe somehow a question / comment relating both presentations. Are any of you aware with what is called lean development in software engineering?
Sorry for my co-organizer.
Are you aware of what is called lean development in software engineering? Lean engineering. Okay.
Not really.
Very, very briefly, because it's related to both the areas. It's something that tries to model the business model, as it's called, of software engineering by looking at two terms, waste and value. They say, well, you want to generate a lot of value, engineering, manufacturing, and so on, but you want to minimize waste. So if we look at our field and try to find out what is value, we find keywords like publication, impact, and for the lucky of us, some products that we can sell. Now, if we look at waste, then we find not recognized work, IP given away, losing head start because you give your code away to other people, and expose some weaknesses in your own technique that can be seen as waste. So then my question would be, in this view, what is the value, the hard measured value with respect to our research business model in exposing our data / code versus what is the waste of exposing that? Because unless we say that very clearly, it's not very clear where we should do it. Like, what do we tangibly gain by doing it with respect to our business model, not with respect to improving the world and making it a better place, so on. I mean, we do this, but what is the measurable value? Because if we find that, we might be able to find why we want to do it.
Thanks for your input.
Very good point. Very good point. You can
say something and you can say something. So the value is surely citations. Once you
do you have evidence for that you publish?
I do, and now okay. So I've heard it very often. That's fine. I've heard it very often. That's true. Okay. So, but I mean, so I can maybe take a little bit more. So, what is there? Okay, you get citations, so your paper might get more. Huh? No, it's fine. It's all fine. You have the opportunity to collaborate with others. For example, this is one thing. But I'm not sure if you find this. This is all. I mean, as I said before, it's an impact that comes later, much later, and it might never happen. And in that case, yes, your work is waste. But then, if it doesn't happen, if people don't need it, and if people don't use it, and if maybe it doesn't work well, what was it worth then? No? Was it worth anything? Yeah, exactly. It's just a paper. So, it's what value?
For your tenure.
He wants to say something.
Yeah, I'd like to actually also give a bit of a response to that. I think the problem is that there needs to be a culture of having stuff available. Right now, the default is it's not available. So a lot of people don't even look for it, and most people don't have the experience of putting something out there and having somebody else use it and not cite their work. So they don't understand the value of doing this for other people. So whatever you find, you know, if you look for PCA or if you look for something else, you just use the code because you don't care and you don't understand the value of that. But there are lots of other fields where this is actually crucial and really a very, very intricate part of how publication works and how research is done. One example is molecular modeling, where they have thousands of people working on huge libraries. It's all open source work. This stuff gets published in notes all the time, and all of this gets referenced. And they have, and I was at a workshop about a year ago, they talk about tens of thousands of citations every year. I mean, this is a very large field. But there is no question. If you write a paper, you use a method, you cite the method. And everybody does that. And that there's a huge amount of value in that, and they get tons of funding. Another area is bioinformatics. Bioinformatics, no code, no publication. It's a very simple rule. So I know everybody's trying to be nice, and we don't want to stifle research, but if you were serious, again, I'm sorry to repeat this, but if you were serious about science, bioinformatics, biologists who write code, I can tell you it's horrendously bad code. It's written in Perl, which is essentially a guarantee for horrendously bad code, and it's written by biologists, so it's really the worst combination you can imagine. But that has to be published. And no code and no data, no publication. Same is true for so it's not just their code, but it's also data. So things like microarray experiments. You have to publish your data. Your data goes into ArrayExpress, then you can publish your paper. That's a rule, and that's not, I don't know about biostatistics, but all the others like PLOS ONE and Cell and all these other high impact journals, they require that. And we actually had stuff rejected because the reviewers couldn't figure out how to run our system because it had too many setup steps. So I kind of appreciate that problem. But I think there needs to be a cultural shift in how we think about availability of code and about using code and also about citing code. And it's not something that's going to happen overnight. But once that kind of happens, then we'll see a lot of value from that. So I think it's a very good question that Alex is raising here. But I think there's a ton of value in that, and we can see other fields where it's happening already. So we don't even have to find, the 3 papers where people have actually published their code and have gotten lots of citations, because they probably can find those as well in our field. But there are tons of fields that do that.
So actually, in visualization, we tend to think of ourselves as useful for everybody, right? And if the code is available, maybe they will use it. One value that I see from the academic point of view is I would like to have our venues to have a little higher impact rate, and that might help. That might be a value we should be looking at here, from releasing the code and assuming, like in other areas, that this makes more references and more people getting to know it will help improving our rates as in general.
Thanks, Rosane. So
I just wanted to tell you a little story from a project we have, and that is, because we are also heading towards publishing in the bioinformatics community, because we have visualization specialists and from the VRVs here in Vienna. But we are running since 3.5 years a project with the Institute of Molecular Pathology. And they did not yet publish their data. Thus, we cannot publish our software. Yeah? That might then also result in a bit of shift of, we are somehow blocked in publishing what we are doing. There's nobody sees what we are doing. We are developing a huge system, but we are not allowed to publish, or we cannot publish because we have not the data. We cannot say, okay, we generate some artificial data, but that's somehow ridiculous. So that might cause some problems. So there should be something in between. So we would like to publish the code, but we cannot because nobody can use the code without the data.
Okay. Thanks for
It's just a remark, maybe.
Yeah.
But you can publish the paper.
Excuse me?
You can publish the paper.
We could publish the paper, but we want to save it also to publish it in a bioinformatics journal because we say it fits better there. And not in, if we publish it in the visualization community without the data and the code, then it's somehow, then it dies for the bioinformatics journal because they accept only original work. So we are somehow
And they have a higher impact rate, right?
Exactly.
Okay.
Don't they?
Thank you for the discussion, and thanks, Rosane, again. So we're over to other sites, which hopefully will complete the field for the discussion, and then we will continue with the real discussion. So yeah, the next one will be Helmut. You please take over.
No, it's fine. It is correct.